This is a setup with a digital voltmeter set on volts and an analog voltmeter set on 2.5 volts. The purpose of this demonstration is to show you that I have a reading on here which is 6.78 volts, which is between the pipe and the soil at this place. Now, when I take a reading on the analog meter, you will see that reading changes. But it only changes as I get close to the point at which the digital voltmeter is placed. So the half cell, which is this, is placed on the ground, and the effect of the analog meter, and you can see the reading there, has increased, and when I put the reading here it's decreased, and it is drawing current from this part of the electrolyte to drive the meter. When it draws current from this place in the electrolyte, it draws more current, and this is the equivalent of a coating fault. So now I will show you how I set this up so as to explain what you see here. First of all, this is a buried pipeline. This is the negative connection to the buried pipeline. Let me get that into focus there. The negative connection. That negative connection is connected to the battery, a 12-volt battery, but it goes through a variable resistance. Now you can see the reading on this meter change as I decrease, and then increase the resistance in this negative part of the circuit. So in fact there is, sorry, I got it the wrong way around. This is 9.3 volts where there is less resistance. I'll go round here to 8.6. 1.45, 0.86, 6 volts, 9 volts. So I'm varying the resistance in here, which is connecting the battery to the pipe, and the positive of the battery is connected to the steel case in which the electrolyte is placed, and that represents how a cathodic protection setup is arranged. I will now I'll switch this off, switch this one off, take this is the equivalent of the half cell measuring a pipe to soil. This is the connection to the analog meter. This is the negative connection of the pipe to soil meter. This is the drain point, which is connected to the negative of the battery. And this shows you the pipeline, which is buried, and it has two coating faults for other tests, which I will show you later. So, the whole lot is just soaked in tap water. So the charges go into the steel, they go all throughout the whole of the electrolyte, just as they do go to remote earth with a properly designed cathodic protection system. And I can connect this, instead of a battery, I could put a transformer rectifier here, a small one, which is adjustable up to 12 or 15 volts. But for the convenience of this demonstration, I have used just a battery. Okay? That explains the difference in readings that you get using an analog meter and a digital meter, and the effect of the analog meter on the actual electrolyte, the ground itself, when you're making the reading.